everyone. Today we're going to head and go over lesson 3-1, which is solving system of equations. We'll go ahead and get started. We are going to review 2 variable systems, and then later on we'll move to inequalities as well as 3 variable systems. So some important information to note today is kind of like some vocabulary you'll be seeing and we might hear. So we have break-even point, system of equations, consistent, inconsistent, independent, dependent, substitution method, elimination method. So several of these you may have already heard or you may be familiar with when you saw this in Algebra 1, but we're going to head and review some of these topics. So the first one is we're going to have a system of equations by completing a table. A system is made up of 2 or more equations, and pretty much we're just looking to see if they intersect. Are they the same line? Do they never intersect? Those are what we're going to be looking for. So we're going to solve this set x plus y equals 3 and negative 2x plus y equals negative 6 by using a table. So we're going to head and solve for y on each of them, and we get y equals negative x plus 3 and y equals 2x minus 6. So then they go ahead and use a table here, and what we're looking for is an intersection, meaning at some x point they have the exact same y value. So looking at this here, I can see for x1, y1, we're looking for the same set of coordinate points. So we're looking in this column here to see where they're the same, and we can see they're exactly the same at 3, 0. So our answer here would be 3, 0. And as a reminder, we write our solution as a coordinate point using our parentheses, the number, comma, and then closing the parentheses. Let's go ahead and take a look at this problem. Let's go see if you can go ahead and solve it. You can go ahead and get a table together. You can go ahead and graph it, or a method that you do know. All right, so on this one, we are going to go ahead and get B so that we can go ahead and check this quite easily. So I'm going to do 0 plus 2 equals 2. That is true. And then I'm going to do 0 minus 3 times 2 equals negative 6 and check. And I do get negative 6 equals negative 6. That is true, so that is my solution. And we're going to look at a couple other methods. So here we have another one we're actually going to do by graphing, so we'd actually see it. Desmos is really great for this. They're actually really nice at actually labeling the intersection point. So we're going to write each equation in slope-intercept form. Depending on the calculator you're using, if there are no restrictions set on the calculator, then you actually don't have to do this step. But I do know if you are going to be retaking the STAR exam and the calculators are put on test mode, you are required to go ahead and change it to slope-intercept form, meaning y equals mx plus b. And also depending on if you're using the nSpires again, there's a couple other things that you don't get to use depending if you're taking the STAR or they just said a couple things or you're trying to do. Some features are locked depending on how you type them in. But if you are using Desmos with no restrictions, you are able to type this exactly as you see it. You don't have to change it. However, depending on what you're doing or the calculator you're using, you will be required to change it to slope-intercept form. So we're going to go ahead and do that. We get 1/2 x and negative x plus 6. So then we're going to go ahead and graph, and we can see they intersect right here at 4, 2. And of course, as we should always check our solutions by plugging in our answer and making sure that we do get a true statement. And we do get 2 true statements, which is good. So our solution is 4, 2. All right, so go ahead and try example 2, check your progress. Which graph shows the solution to the system of equations below, x plus 3y equals 7, and x minus y equals 3. All right, so here we're going to go ahead and take a look at these. One of the things that actually might be easier if you're trying to figure out what the lines are is to go ahead and change it to standard vertex form. So I know this first one is y equals 7/3 minus x over 3. So that does give me a couple of things. The second one will be, we get negative y equals 3 minus x, and with that negative, it becomes x minus 3. So that's going to be very helpful to know that I'm looking for one that is going to cross at negative 3. So I'm looking at this. I'm automatically going to cross out A. I'm automatically going to cross out B. I'm also going to cross out, oh wait, you're not going to cross out A. You're going to cross out C and B. Just because they do not have a point going through negative 3. So I'm going to head and cross out C. So looking at these two, I do know I cross above the x-axis here for the second one. So I'm going to cross out D because it doesn't cross above the x-axis for the second equation. And so by process of elimination that way, I do get A. I could also go ahead and graph these and look at the graph and see them, and see that we do cross at 4, 1. But by knowing your y-intercept, negative 3 and 7/3, which is 2.33, never ending, that would be very helpful when you're looking at graphs. All right, so next we're going to take the look here at the system of equations and describe it as consistent, independent, or consistent and dependent, or inconsistent. So consistent and independent and consistent independent are going to describe two types of solutions we have. We either have one solution, and then we have infinite solutions, meaning they're exactly the same line. And these will just both be consistent. Now, if it's inconsistent, it's just going to be no solution. So we're going to head take a look and identify which one's which as we go through. So here we have x minus y equals 5 and x plus 2y equals negative 4. So we're going to head and write each equation in slope-intercept form. And we get x minus 5 and negative 1/2 x minus 2. And by graphing, we find that we have one solution at 2, negative 3. And because there's one solution, it is consistent and independent. Next, we're going to go ahead and graph the equations 15x minus 6y equals 0 and 5x minus 2y equals 10. So we get y equals 5/2 x. And y equals 5/2 x minus 5. So when we graph these, we see that they are parallel lines, meaning they're never going to touch. And we're able to tell that when we did graph these, we did get 5/2 x for both our slopes. So that tells us it's inconsistent because they're never going to touch. So there is no solution. So next we're going to go ahead and try graphing the system of equations below, and what type of system of equations is shown for x plus y equals 5 and 2x equals y minus 5. So I'll give you a moment to go ahead and do that. Again, pause as needed. All right, so if you were to graph these, you would see we have one solution, so they are consistent and independent, and it looks like it's at 0, 5. So we're going to head and try this one and determine whether the type of solution we would have. So we have y equals 3x plus 2 and negative 6x plus 2y equals 10. Again, pause the video as needed. All right, so here we find that they are parallel, so this is being inconsistent. So without we going over two of them, it's actually a little harder to show you the third option. So we do have a little set of notes here that describes the characteristics of linear systems. So if there's one solution, it's consistent and independent. If it is, when you graph it, ends up being exactly the same line, they're just written in different ways, it's going to be consistent and dependent, meaning that every point on that line is a solution. And then we have inconsistent, which is parallel lines and no solution. So next we're going to take a look at substitution method. Again, this may be one of the methods you did see back in Algebra 1. So we're going to solve for one of the equations for one of the variables, and then substitute that value or that expression into the other equation to solve for the other variable, and then substitute and solve for the remaining variable. So this is a lot of going back and forth. So here we have a word problem. So one of the other things you'll be required to do is write a system of equations based on a word problem, which I do know you did get a lot of practice back in Algebra 1. So here we have Lancaster Woodworkers Furniture Store builds 2 types of wooden outdoor chairs, a rocking chair that sells for $265 and an Adirondack chair that with a footstool that sells for $320. The books show that last month the business earned $13,930 for that 48 outdoor chairs sold. How many of each chair were sold? So we need to come up with 2 equations to go ahead and solve for this. So we're going to let X be the number of rocking chairs, Y be the number of Adirondacks. So we know we sold 48 total, so X plus Y equals 48. And we also know the amount of money earned was $13,930. And we know that a rocking chair is $265 and a Adirondack is $320. So we're going to head and solve. In this case, we're going to head and solve in terms of Y. So we're going to isolate Y and we're going to isolate X. So in terms of Y, X is 48 minus Y. So now I'm going to substitute 48 minus Y in for X on this second equation. So everywhere I see an X, I'm going to do 48 minus Y. And then I'm going to head and simplify. So we're going to multiply and then combine like terms by using distributive property. And we end up, when simplifying, we get 55Y equals 1210. We're going to head and just divide and get Y equals 22. So now I'm going to take this value here and plug this into the other equation to go ahead and solve for X. So if we know X plus Y is 48 and Y is 22, I then can find out that X is 26. So they sold 26 rocking chairs and 22 Adirondack chairs. When doing this, sometimes it just depends on which equation. You kind of need to take a look at it and see which one's going to be easier to do. And the more you practice it, the better feel you get for which one you should go ahead and do substitution on. You can also check this, and you see that if you graph your 2 equations, they would be in intersection. And so go ahead and pause the video to go ahead and have a chance to work this one out on your own. All right, so let's take a look here. We have at Amy's Restaurant Amusement Park, tickets sell for $24.50 for adults and $16.50 for children. On Sunday, the park made $6,405 from selling 330 tickets. How many from each kind of ticket were sold? So I do know I'm going to use A and C. So A plus C needs to equal 330. And then I know that 24.5 A plus 16.5 C equals 6,405. So I'm going to head and solve in terms of C. So I'm going to do A equals 330 minus C. And I'm going to substitute that into this equation. So I'm going to do 24.5 times 330 minus C plus 16.5C. And that should get me 6,405. So I'm going to do 24.5 times 330. And we're going to get 8,085. minus 24.5 C plus 16.5 C equals $6,405. So now we're going to head and I'm going to subtract 80.85 from both sides and combine like terms. And so we're going to do, let's see, 16.5 minus 24.5. So we're going to get negative 8C equals a negative 1680. So divide that by negative 8. And we're going to get 210 equals C. I can plug this in and know that I will get, if 210 is C, 120 is for the adults. And I can plug that in and solve for A that way. But my answer is B. When you are working these out by hand, I do suggest having a sheet of paper. It does take a little bit of space to work them out. And it is worth actually having a sheet of paper to work these out. You'll have an easier time doing it. Next, we're going to take a look at elimination. This is another method. Step 1 is multiply one or both equations by a number to result in two equations that contain opposite terms. Step 2, add the equations, eliminating one variable, then solve the equation. And then step 3 is substitute to solve for the other variable. So here we have x plus 2y equals 10 and x plus y equals 6. So in this equation, each coefficient of x is 1. If we subtract one from the other, we can go ahead and eliminate x value. So when we subtract, we're subtracting everything. So sometimes it's actually easier to rewrite this equation as negative x minus y equals negative 6 and just multiply everything by the negative. Because if you do this method, we tend to have a lot of people that, even I've done it in the past, that they'll forget they're subtracting and they just look here 2y plus y and they'll put 3y. So do make sure you are careful when you're doing subtraction. Sometimes it's easier to just go ahead and multiply by the negative and then add like normal. But with this, we get y equals 4. So now we're going to substitute this into one of the equations and solve for x. And we get x is 2. So my answer is 2, 4. This one's more of like a method when you know which one to use. It's kind of up to you. You got to look and see. But this is an option that we do have. So next we're going to head and use elimination to solve the set of equations x plus 3y equals 5 and x plus 5y equals negative 3. So I will go ahead and give you a moment to go ahead and do that. Again, pause the video as needed. All right, so let's go ahead and see here. We would eliminate x again. So I'm going to multiply the second one by a negative. So I'm going to do x plus 3y equals 5. And we're going to have minus x minus 5y equals 3. And we're going to go ahead and add. My x's cancel out. And I have 3y minus 5y, which is negative 2y. And 5 plus 3 is 8. So then I'm going to solve for y and divide that by negative 2 and we get negative 4. So since y is negative 4, I'm going to head and do 3 plus, x plus 3 times negative 4 equals 5. So x minus 12 equals 5. And I get x equals 17. So my solution is 17, -4. So our answer again is B. So we do have that. How interesting. So we have there we go. So we're gonna head and solve another one, which have no solutions or infinite solutions, is what they're gonna go with. But we're gonna solve 2x plus 4y equals 12, and -5x minus 10y equals -30. So one of the things we are gonna head and do, sometimes it's required that you do need to multiply top and bottom to get what we need. So here they've decided they want to eliminate x. We'll multiply the top by 5 and the bottom by 4 or by 2. And when we do that, we get 10x plus 20y equals 60. And then we get -10x minus 20y equals -60. And of course, when we go to eliminate, in this case, we get 0 equals 0. This is a special case because with 0 equals 0 is a true statement. This means that there are infinitely many solutions. If you ever get something that says like 1 equals 0, this would be no solution. Or anything like that. But here, if you get 0 equals 0, that is infinitely many solutions. So go ahead and take a look here at x plus 3y equals 7 and 2x plus 5y equals 10. All right, so in this one, we need to go ahead and decide kind of what we want to eliminate. I would eliminate x because that's going to mean I only need to multiply 1. If I wanted to eliminate y, I would have to multiply top and bottom. So I'm going to multiply the first equation by -2 so that I can get an opposite coefficient for my x's. And when we do this, I'm going to get -2x minus 6y equals -21 or -14. So then I'm going to head and add 2x plus 5y equals 10. My x's cancel out, and I'm left with -6y plus 5y, which is -y. -14 plus 10 is -4. And then I get, simplifying that, I get y equals 4. So then I'm going to head and plug in 4, so 3 times 4 equals 7. So I'm going to get 12, x plus 12 equals 7. So subtract 12. And we get x equals -5. So my answer is -5, 4, which when we see that, we do get C. So when we're taking a look at solving system of equations, here is a table of when like the best time to use. Table, it's nice if you have an exact solution. This might not always work if your input's not a rational number or a whole number, depending on how you're working it out. Graphing can give an estimate. So pretty much this might be a good idea to way to check it to see where it falls. But if your answer is a decimal or a never-ending decimal, whatever it might be, this might not be the best way to go. And I am going to make a point that generally you do need to be very careful, especially if you're submitting answers in Desmos, or I'm sorry, not Desmos, in ALEKS. When they tell you to plot coordinate points and to list something, they'll sometimes tell you not to round it. They want the exact answer. So they might want a fraction. So this one's harder to get if they want an exact value. Substitution. This usually almost always works, so you shouldn't have to worry about it. It's really great if one of the variables are already at 1x as just an x or just a y, or even just a -x or a -y. Elimination and substitution pretty much always will work, especially if you're using multiplication. Addition works if you already have a set of coefficients that are opposite for a term. Subtraction is if you have the same coefficient for a term. That is the end of our lesson for 3-1. Next, we'll be taking a look at inequalities. So I will see you next time, and have a nice day. Bye.